So, real quick before I head to bed, because I actually got school tomorrow, I'm making this video on hypothesis testing and why you should never accept the null hypothesis. I'm gonna assume you already know how to conduct a hypothesis test, and you already know what binomial distribution is. Yeah, this is gonna be a short video, but let's just get into it. Well, actually, let's first talk about why I'm making this video. So, if you look at how some people answer hypothesis testing questions in some exams, you might see that they accept the null hypothesis, like in this case and in this case. And also in the textbook, they, well, if you do further statistics 1, you learn about type 1 and type 2 errors. Even the textbook gets this wrong, and they say you can accept the null hypothesis. But that doesn't really make sense if you think about it. And to explain, let's use an example. This is an actual exam question. So we got a supplier, and they claim that when they supply bags of sugar, the proportion of bags that are damp are less than 8%. So we take a random sample of 70 bags, and we find that only 2 bags are damp. And they ask us to do a hypothesis test, but I'm not going to teach you how to do that in this video. So this is the mark scheme. They just go through the regular hypothesis testing with binomial. And at the end of it, we find the p-value to be less than our significance level, so we reject the null hypothesis. But, I mean, let's just say, for example, we take another random sample of 70 bags, and we find that only 3 of the bags are damp. And then we redo the same hypothesis test, but instead of 2 bags being damp, we have 3. So that's just going to be the probability that x is less than or equal to 3, and that equals 0.1790, and so on. And that's bigger than our significance level. So what some textbooks might tell you to do is, from here on, conclude that you can somehow accept the null hypothesis, which is completely wrong. Because, I mean, like, the language here is accepting the null hypothesis. And when you say accept, you sort of imply that you've somehow proven the null hypothesis to be true. So you're sort of implying that you've proven that the probability is equal to 0.08, which doesn't really make sense, because let's say p was equal to 0.079, and then we conducted our hypothesis test from there. We'd still have a p-value that's greater than 10%. So the conclusion there is that if we use a probability of 0.079, we'd still accept the null hypothesis then. But that would mean that with both of these hypothesis tests, we're sort of saying the probability is 0.08 and the probability is 0.079, which doesn't make sense. That might have been confusing, but basically what I'm trying to say is, when we've conducted this hypothesis test, we haven't proven anything. So we cannot, like, say for certain anything is actually true. We cannot accept the null hypothesis. We can only either reject the null hypothesis or say that we cannot reject the null hypothesis. So we do not reject the null hypothesis. The only thing we've done in this null hypothesis, or the only thing we can say, is that a probability of 0.08 is plausible in this example at the 10% significance level. So, I mean, maybe I went on a little bit of a ramble, but hopefully that made sense, you know? If I said something dumb, then, you know, you can ignore this video. I mean, this video wouldn't even be up if I said something wrong. You wouldn't be seeing this video. But hopefully that made sense, and let's just hope that I didn't say anything wrong.